Hi everyone. So we will continue our next topic of electrolytic cell. Before this, let's compare how a electrolytic cell is different from the first cell which we studied, electrochemical cell or galvanic cell. Electrochemical cell or galvanic cell or Daniel cell, whatever you call them, electrochemical and electrolytic cell. Lytic means breaking. In electrochemical cell, you must be remembering that there was some chemical energies which was changing into electrical energy, right? The chemical energy was getting converted into one way only. The chemical energy was getting converted into electrical energy, right? But here in electrolytic cell, the opposite will happen. What will happen? The electrical energy will be converted into chemical energy, right? And here in electrochemical cell, I told you to remember one word, that was lone, right? Left side oxidation will be taken care by anode, and one important thing here, anode here was negative, right? Anode here was negative. But in electrolytic cell, things will become opposite now. Here the anode will be positive and your cathode will be negative. Now you know electrical energy is converting into chemical energy. It means we are already providing electrical energy so that you get chemical compounds. That's our main agenda of electrolytic cell. What was our main agenda of electrochemical cell? That you have to produce electricity. In electrolytic cell, we want some chemical compounds from electricity. Okay, but don't worry, this anode is negative, here anode is positive, but both anodes are doing oxidation. Anode's role is only to do oxidation. Okay, so with this comparison, let us now start with our electrolytic cell. Electrolytic cell. What does lysis means? Lytic means breaking of the compounds. Breaking of chemical compounds, that's your lytic meaning, breaking of chemical compounds. Okay, and here your electrical energy is being converted into chemical energy. And how does your cell looks like? Your cell will look something like this. It's a container having your two electrode. One is your anode and the other one is your cathode. Here you are having electrolyte. You are having your electrolyte. This is your electrolytic tank which is filled with any of the electrolyte. Now and this anode and cathode is connected by a battery. And in electrolyte, you know, you have anions also. And I told you anions will be negative charge, right? Cations are something which are positive charge. Now, when we supply energy, I told you anode is something which is opposite of that different cell, electrochemical cell. So, anode here will be not negative but positive. Lone formula we apply only for the Daniel cell, the electrochemical cell. Anode here is positive, so your positive ions will come here, like anode will be positive and cathode will be negative here. Now what will happen? Opposites attract, right? So your cathode being a positive charge will go towards your cathode. Sorry, your cation being a positive charge will go towards cathode, and anion being your negative charge in the electrolyte will go towards your anode. So what is happening here? Anion goes to anode. Anion goes to anode and cations will go to cathode. The formula, like the trick to remember this is just remember A goes to A, anion goes to anode, C goes to C, cation goes to cathode. But just remember anode and cathode will do oxidation and reduction respectively, like your electrolyte electrochemical cell. But anode will undergo the same way oxidation and cathode will undergo reduction here also. So why there are some anions and cations here? Because your electrical energy is breaking down that electrolyte into an anion, into a cation. Okay? The electrical energy is breaking your electrolyte into your anion and cations. Now the first thing, when cation, first thing what is happening, your cations is going to cathode. Like if your, not if, cations are going towards your cathode. In cathode what happens? Reduction happens, right? Reduction means loss of electrons or gain of electrons. Just remember this, oil rig. The word to not get confused with oxidation and reduction. Oxidation is loss of electrons, reduction is gain of electrons. So C plus is going to cathode. So cathode, your C plus will accept an electron to become C. And here your anions are going to anode. In anode what happens? Oxidation. Oxidation is loss of electrons. So anions will lose an electron, minus electron, right? Or you can simply write it as anions will lose an electron to become A plus plus 1 electron. This full process is called as electrolysis. This full process, whatever is happening, it's called as electrolysis. And this happens inside the electrolytic cell. Okay. Next topic, like next is what we have to study is factors on which the products of products at electrode depend. The factors on which products at electrode will depend. The first factor is definitely the nature of electrolyte, like what electrolyte are you taking. So depending upon that only your cations and anions will form, right? Nature of electrolyte. So you can take your KCl, your NaCl, your MgBr2, anything, right? So nature of electrolyte, it depends upon the nature of electrolyte. Second is your medium of electrolyte. Medium of electrolyte, that whether it is your aqueous, it's in aqueous condition or molten condition. Molten means you are simply melting that electrolyte or you are adding water into it. Aqueous means adding water into it. The third thing which you need to remember is concentration of electrolyte. Medium of electrolyte, then concentration of electrolyte. This will study in more detail. Concentration means whether it's dilute or you're concentrated. Concentrated means only electrolyte is present. Dilute means you're adding a lot of water into it. That's dilute. Concentration of electrolyte. Then fourth is your nature of electrode. Fourth is your nature of electrode. That whether the electrode is inert or whether the electrode is inert or your active. Inert means it's not participating in the reaction. Not participating in the reaction. And the active means it is participating in the reaction. It means participation in the reaction. Okay, so these are the factors on which the product at the electrode depends. What is happening basically is you are taking the cell, you have anode, you have a cathode, both are connected by and battery, electricity is flowing. You are taking any electrolyte, say NaCl electrolyte I am taking. So NaCl electrolyte will break into Na plus and Cl minus. Why? Because it's electricity. Na plus will go to your cathode, Cl minus will go to your anode. So now we know we have got the products Na and Cl minus. Na2, like whatever, like we'll see it later. Now how do we determine which products are formed? Rules for product formation. Rules for product formation. First rule is that you have to assume inert electrode. You just need to assume, unless it is mentioned, just assume that there are some inert electrodes, means they are not participating in the reaction. Assume your inert electrode like platinum, unless mentioned. If it is not mentioned that your electrode is actually participating in the reaction, just assume they are inert electrode. Second is, try to write anode reaction first. What do we have to do? We have to write the anode reaction first. The third thing is, in case of active electrode, in case of active electrode, all reaction will stop. Active electrode means something which is participating in the reaction. All reaction will stop and electrode themselves start oxidizing and reducing. Electrode will themselves start oxidizing and reducing. So these three rules, this practically will see case by case. First thing is, you have to assume everything is inert electrode unless it is mentioned. Second thing, write the anode reaction first, it will become more easy. Third thing is, if there are active electrodes, all reaction will stop and the electrode will themselves starts oxidizing and reducing. This will see case by case for more clarity. So we'll see how this electrolysis actually happens. Case 1. Case 1 is when we are taking molten electrolyte. Molten electrolyte. What do you mean by molten electrolyte? Molten electrolyte means we are just melting the electrolyte. Case 1 will see okay. Case 1 example will be, like first example let me write, electrolysis of NaCl. First example is electrolysis of NaCl which is molten with any inert electrode, say platinum electrode. So now you know what we are doing is, we are taking NaCl in this tank, electrolytic tank, and you have this anode, this is a cathode. Both are made up of platinum since it's an inert electrode and it's connected to a battery. Anode is your positive here, cathode is your negative here. and what you have done, you have added NaCl. Now NaCl is getting broken down into Na plus and Cl minus. Why? Because of electricity. Na plus, where it will go? It will go to cathode, and your Cl minus will go to your anode, right? So what is happening in your anode actually? What happens in your anode? In anode, oxidation happens, right? So how will the reaction take place? The reaction will take place as Na plus, oxidation, right? Oxidation means, sorry, 1 minute. In anode, what do you have? Anion go towards anode, right? Anion, Cl minus is going towards anode. So you are taking Cl minus, and oxidation is loss of electrons, right? So a Cl minus is losing the electron to become Cl plus 1 electron. Now any 17th group element will not exist alone. They don't want to live alone. They cannot live alone because it's not practically possible. So what will happen? Your chlorine will combine with another chlorine molecule to give you Cl2. Okay. So you can write it like this, or you can simply write it in a simple equation. And what will be that simple equation be? Just take 2 Cl minus ions. 2 Cl minus ion is giving you Cl2 plus 2 electrons, right? Since chlorine will always exist as 2 Cl2, like Cl2, that's why we are writing 2 Cl minus we combine, so to give Cl2 plus 2 electrons. Nothing we are doing, just multiplying this with 2 so that you get Cl2 here. So this is the reaction which is happening at anode. Next reaction will happen at cathode. In cathode, what thing went? Cation went. Our cation was Na plus, right? So here your Na plus will be accepting an electron to give you Na, right? But we have studied in your previous examples that whenever such kind of reactions happens, you need to balance these electrons, right? So here you have just one electron. Just multiply the whole reaction by 2 so that you get in total 2 electrons. So this one will be 2 Na plus 2 electron is giving you Na. Okay. So what is formed at anode? What gas we are getting at anode? We are getting Cl2 gas at anode, and sodium is formed at cathode. So at cathode you are getting Na, and at anode you are getting a chlorine gas. Okay, so this is very easy, right? Electrolysis of NaCl, you are just pouring NaCl in an electrolytic cell. You have an anode and cathode. Your reactions are not taking place there. So in anode, your anion is going. What is our anion here? Cl minus is our anion, right? So Cl minus is going to anode, going oxidation to give Cl minus is giving you Cl plus electron. Cl plus Cl is combining together to give you Cl2. And similarly in cathode, your sodium is formed. So what is the final reaction? Final product. Cl2 at anode, and your sodium is formed at cathode. This is a final product. This was case 1, okay? Case 1 of molten electrolyte, electrolysis of NaCl. Second example we'll take is of electrolysis of MgBr2. Second example, same case, molten electrolyte. We are just taking molten electrolyte. Second case we are taking is electrolysis of molten MgBr2. Molten MgBr2 with platinum electrode. Electrolysis of molten MgBr2. You know the setup now, right? Just identify how will this electrolyte MgBr2 break down. MgBr2 will break down as sorry, MgBr2 will break down as Mg2 plus and your 2Br minus. So this is your cation, this is your anion. Cation will go to your cathode. Cation goes to cathode and this thing will go to your anode. What will be the reactions now? Right anode reaction first, right? So anode, your oxidation will happen. Oxidation means loss of electrons. So 2Br minus is giving me 2 electrons plus Br2. And in your cathode, your reduction will happen and Mg2 plus will accept 2 electrons to give you Mg. So in cathode, what is forming? Your Mg is forming. So product at anode is Br2 and product at cathode is Mg. Easy, right? For molten electrolyte. This was the case of molten electrolyte. Electrolysis of molten MgBr2 with platinum electrode. Third, one more example. Let's take one more example. Let's take one more example of electrolysis of AlCl3 with platinum electrode. Why platinum electrode? It's an inert electrode. What will you get? Just try to break this reaction. How do we break it easily? Just write Al and Cl here. What the number is here? On Al, subscript is 1, right? On Cl, it's 3. Just cross multiply it with the sign. So what will you get? Al 3 plus and Cl minus. Now since we need to balance the charge, we do 3Cl minus. Okay. This is your cation. Cation goes to cathode. This is your anion. Anion goes to your anode. In anode, what thing happens? Oxidation. So how will you write the reaction? The reaction will be 3Cl minus is giving you. Oxidation means loss of electrons, right? So how many electrons will be get lost? Instead of Cl minus, we'll be writing Cl2 plus 3 electrons I'm writing, okay? And in cathode, how will you write? Al3 plus will accept 3 electrons to give you Al. Right? So what is being generated at cathode and anode? Al and Cl2. Okay. You know, Cl is always, one more tip I'll like to give you so that you never go wrong in these kind of questions. See, Cl is always liberated as Cl2, right? So we cannot write here 3Cl, although it's 3 here. But it's better if you write this kind of reaction. 2Cl minus is giving you Cl2 plus 2 electrons. Now if you need to like balance this electrons, multiply this by 2, multiply this by 3, so that you get in total 6 electrons each side. So this will be 2Al3 plus 6 electrons is giving you 2Al. And this one will be 6Cl minus is giving you 6Cl2 plus 6 electrons. Okay. So what are we getting here? We are getting aluminum, same thing only, but to maintain the stoichiometry we are doing this thing. Chlorine is liberated at anode and aluminum is liberated at cathode. So this was your case 1 of molten electrolyte. You're just melting the electrolyte, nothing else, no water, nothing. Then now we jump to case 2. Case 2 will be your aqueous electrolyte. Case 2 is your aqueous electrolyte. Aqueous means you're adding water also, right? You're adding water also. So let's take a first example as electrolysis of NaCl with platinum electrode. By platinum electrode, that's an inert electrolyte. And NaCl we're writing aqueous. Now this particular thing has also two things. Whether it is a dilute solution or concentrated solution. Dilute means lot of water is added. Concentrated means very little water is added, might be added. But if nothing is given, we just assume that it is concentrated. Okay, so our A case is if it is concentrated NaCl. Concentrated NaCl. Now there is water also present, right? So see, Na is definitely there in the electrolytic cell. Along with NaCl, you have water also. So water will also break down, right? So NaCl first breaks down into Na plus and Cl minus. And your water is also breaking down into H plus and OH minus. Now can you see we got 2 cations and 2 anions, right? In anode, what thing will go? Anode anions. And what all anions are present with us? Cl minus and OH minus. And in cathode, what all things will go? Your cations. And what all cations are present with us? Na plus and H plus. Now there is a confusion. What thing will actually be liberated in anode and actually at cathode? Because there are two things, right? 2 anions and 2 cations, right? So now what is our confusion? Which one will get liberated? So the answer to this is preferential discharge. Preferential discharge. So this thing is a series. You need to learn a series of elements. Linazen, FeH, copper, AgCl minus, OH minus, NO3 minus, SO4 2 minus and F minus. Do you remember in our electrolytic series electrochemical series we used to think cathode should be more lower, right? Same thing only here. Cathode should be more lower, anode should be more upper. So in cathode you just check which one is, because cathode should be higher, right? So in cathode, see, check cathode what all things are there, Na plus and H plus. You need to check which one is more lower. Yeah, more lower, because your SRP is increasing. So among Na and H, where is our Na? Here, and H is here. Now we need to check which one will be liberated. Hydrogen will be liberated, right? Why? Because we are seeing which is down. So here hydrogen won the battle. Next we have to take in anode which one is more upwards. So you have the option of Cl minus and OH minus. Cl is here, OH is here. Which will win? Cl has won the competition. So now we got from the preferential, like this thing you need to learn, preferential discharge series. Now we exactly know what all things are there. We just need to write the reaction. Cl minus, I told you, just remember this thing. 2Cl minus is giving you Cl2 plus 2 electrons. Wherever Cl comes, write this reaction. And for H plus, right, 2H plus 2 electrons is giving you H2. So now you know anion, chlorine is getting liberated, and in your cation part, cathode part, your hydrogen gas is getting liberated. Okay, hydrogen gas is getting liberated and your NaOH is formed as a product. NaOH is formed as a product, your chlorine gas is getting liberated at anode, your H2 gas is liberated at cathode, and your HCl is NaOH is formed. Now NaOH is giving you Na plus and OH minus, right? Lot of OH minus you are getting. So because of this, the pH also increases. More OH minus means more pH, correct? And what will be the net reaction? Net reaction will be 2Cl minus plus 2H plus is giving you Cl2 of gas plus H2. Same things only. Just need to add your 2NaOH. Okay, this is how your electrolysis of NaCl with platinum electrode takes place according to your preferential discharge theory. And also remember, this is your concentrated HCl, not much water is added into it. Okay, next type we'll see, it's an aqueous electrolyte only, but this time we'll take a dilute electrolyte. The B part will take dilute NaCl, dilute aqueous NaCl with your platinum electrode. Same things but with a twist. NaCl, you are getting it as Na plus plus Cl minus. Water is breaking down into H plus and OH minus. In anode you have anion, Cl minus and OH minus. And in cathode you have cations, Na plus and H plus. Now we have a confusion which one will come. According to preferential discharge theory, you were knowing which one was coming. Here hydrogen was coming and here Cl was coming, right? But here that's not the case. Why? Because it's dilute. NaCl means lot of water is there. So we'll not consider this preferential discharge theory and directly select OH minus and H plus here. Because H plus and we're directly selecting this because H plus and OH minus is in more quantity. Because H plus and OH minus is in more quantity. And how will your reactions look like? The H plus reaction will look like as, okay, I'll just remove this preferential theory because now it's not important because you are taking dilute things. The H plus reaction will look like 2H plus 2 electron is giving you H2 here. Like in cathode your reduction happens, right? Reduction is gain of electrons. Is giving you 2 electron. And here you need to see OH minus is there, right? So the reaction which happens here is OH minus will liberate an electron and OH. OH now cannot stand alone. So it will combine with 2 OH molecule. Actually, 4 OH molecules. So that's why we are writing 4 here. 4 OH molecules to give you 2 times of water plus 2 oxygens. two oxygen will again combine to give you O2. So in single line, how we can write it down? 4 OH minus is giving me 4 electrons plus your 2 H2O. See, this and this get cancelled. Plus this and this also got cancelled. Plus O2. Okay. Now they have a total of 4 electrons, right? So in order to make the electrons balanced, we'll just multiply also all this reaction by 2 so that you get equal number of electrons. So here it will be 2H plus 4 electrons is giving you, here it's H2, will be giving you H2. Okay, so these are your final equations, A and B. These are your final equations which happens. Four electrons, yeah. So this will be 4. Now what will be the overall reactions which will be happening? Like just combine A and B. 4H plus 4 OH minus is giving you H2, 4H2, sorry, 2H2 plus 2H2O plus oxygen. Overall what happens? You are getting 2 moles of H2, 2 moles of water, 2 moles of Cl2 also. Yeah, 2 moles of Cl2 also, because chlorine will also get liberated. Not anywhere else, but it is there. And your 1 mole of this. This is the case of aqueous electrolyte. You just need to consider water as well. Do the, like just take H plus and OH minus, write the reactions, you will get the products. So in anode, obviously, your oxygen is getting liberated. In cathode, your hydrogen is getting liberated. Okay, this is how your case 2 is of aqueous electrolyte. Case 1 was for dilute electrolyte, and case 2 was for aqueous electrolyte. Sorry, molten electrolyte. Case 1 was for molten electrolyte. Then you have aqueous electrolyte. In aqueous also 2 conditions, concentrated and dilute. In concentrated, we just check the preferential discharge series, and in dilute we are just seeing that H plus and OH minus is there. Okay. Then comes case 3. Now in both these cases, you must have noticed that your electrode was not active. They were inert electrode, right? In case 3, we'll notice that the electrodes are also taking part. We are taking aqueous NaCl, which is concentrated. Concentrated means not much water, with mercury. Mercury electrode is called as Hg amalgam electrode. Amalgam. Now amalgam electrode you are taking as cathode. Now if, like we studied in the initial topic, that if your any electrode is active electrode, you don't need to consider anything else, only this electrode will undergo oxidation and reduction, right? So since this is aqueous, what is happening? NaCl is breaking down into your Na plus and Cl minus, and your water is breaking down into H plus and OH minus. Now let's write both the reactions. What happens in your anode? Anode, just take platinum electrode only because nothing is mentioned, right? And in anode, anions come. What are our anions? Anions are your Cl minus and OH minus. Among Cl and OH minus, you just need to check the preferential discharge series also among Cl minus and OH minus, whichever comes above. Let me check Cl minus and OH minus. Cl is coming above, so your chlorine will be liberated at the anode. 2 Cl minus is giving you 2 electrons plus your Cl2. Your chlorine is getting liberated. And at cathode, what is happening? you have Hg, right? What two things are coming here? Na plus and H plus are coming. According to the preferential discharge theory, H plus should give the reaction, but this is not so. Why? Because your 2 Na plus 2 electrons is accepting the electrons to give you 2 Na, and now this Na is combining with your Hg to give you sodium amalgam. This is called as sodium amalgam. To give your sodium amalgam. Now sodium is highly soluble in Hg, so that's why sodium gives the reaction. Sodium is highly soluble in Hg, that's why our sodium is giving the reaction and not your H plus. Understood? And there is no effect on our pH since H plus and OH minus have not been used, so that's why no reaction on the pH. This was a case 3 with mercury electrode. Okay. Case 4 and the last 4, I know it's too long video, but this is the last case. Case 4 is your aqueous NaCl. Aqueous NaCl you are taking with silver electrode. You are taking it with silver electrode, okay? Silver is an active electrode, okay? So, in anode, what is happening? You have Cl minus also. You have OH minus also along with Ag. And what will happen to Ag? Ag is simply giving you Ag plus plus 1 electron. Loss of electrons. And in cathode, what all things are present? You have Na plus, you have H plus, and you have Ag plus here. Here your Ag plus is accepting electrons to give you Ag. And this is how your process of electro refining works. How does it works? You're taking anode and cathode. This is how the process of electro refining works. You're taking anode, you're taking cathode, connecting it to electricity, and after some time, like what you are doing is, in cathode you are putting the pure metal. This is your pure metal, and here you have impure metal. After some time, what will happen? This will decrease in its diameter and this will increase because you are refining it. You are cleaning all the impurities from that. So this is a case for aqueous NaCl with silver electrode. So 4 things we studied today. First thing was electrolytic cell. How does an electrolytic cell works and what all things are liberated in the anode and cathode. Next thing we studied was cases. Case 1 was molten electrode if we are taking. Case 2 was if we are taking aqueous electrode. In these aqueous electrode. In this also there were 2 cases. First one was if it is dilute or it is concentrated. Mostly it will be concentrated. In dilute you just need to take H plus and OH minus, and concentrated you need to focus on the preferential discharge theory. Next was with silver electrode as cathode. Mercury electrode. Whenever mercury is there, just remember sodium reacts with mercury the most. So mercury forms. Fourth one was with silver electrode. In silver electrode, mostly used for electroplating. One anode is decreasing in size and your cathode will be increasing in size. Okay, so these are the 4 cases. Now from next video, we'll be seeing about your Faraday's law. I hope everything is clear. Thank you so much.